I'm Miss Peart.
And I'm Miss Ryan.
Let's get started. On the lesson opener, we want you to write down as many perfect squares as you can. But what is a perfect square?
Well, it's the product of a number and itself. So like 1 squared is 1, 2 squared is 4, so 1 and 4 are perfect squares. Pause, list as many as you can. Check your perfect squares. Did you get even further?
Yeah, like 13 squared is 169, 14 squared is 196, and 15 squared is 225.
We'll get back to these later. Today, our goal is to learn how to simplify square roots. Now, it's really important when we're listening to learn that we pause, rewind, rewatch as needed.
This is a good time to make sure you have 3 colors ready.
Okay, first thing we're gonna look at are some divisibility tools. We'll use this in all math.
And it's really cool.
A number is divisible by 2, well, if it's an even number, of course. That one we kind of already know.
A number is divisible by 3 if the sum of the digits is divisible by 3. That sounds a little confusing. Let's practice. 381, 3 plus 8 is 11, plus 1 is 12. 12 is divisible by 3, therefore 381 is divisible by 3. Let's look at another example. What about 217? Well, 2 plus 1 plus 7 is 10. 3 goes into 10, but not nice and even. So 217 is not evenly divisible by 3. Let's stick with this column. If I move down to 6, any number that is divisible by 3 and is even will be divisible by 6. That makes sense, right? Now let's take a look at how do we know if a number is divisible by 9? Well, it's very similar to 3. If we add the digits and the sum is divisible by 9, then that number is divisible by 9. Let's look at a couple of examples. 1,629. 1 plus 6 is 7, plus 2 is 9, plus another 9 is 18. 18 divided by 9, 2? Yes, 1,629 is divisible by 9. The next example, 2013, well, that adds up to 6. 6 divided by 9? Well, it's 2/3, but it's not evenly divisible. So 2013 is not divisible by 9.
Let's take a gander back up at 4. We know a number is divisible by 4 if the last 2 digits are divisible by 4. So 1,312. Well, last 2 digits are 12. 12 divided by 4 is 3. So 1,312 is divisible by 4. 7,019. Last 2 digits are 19. 19 divided by 4 is 4 3/4, so not divisible by 4. We know a number is divisible by 5 if the last digit is 0 and 5. That's another one we're pretty familiar with. Ooh, 7. This one's sneaky. We know a number is divisible by 7 if we double the last digit and subtract it from the number made from the other digits. The result must be divisible by 7. Okay, let's hang together on the example. 672. Last digit is 2. If we double 2, we get 4. 67 is the number left over from the other 2 digits, so 67 minus 4 is 63. Is that result divisible by 7? Yeah, 63 divided by 7 is 9. So 672 is divisible by 7. Let's try it again. 905, the last digit is 5, so we double 5 and get 10. 90, so 90 is the number left over, so 90 minus 10 is 80. Is 80 divisible by 7? Nope. So 905 is not divisible by 7.
Okay, divisible by 8. Well, if the last 3 digits of a number are divisible by 8, then that number is divisible by 8. This one is getting a little bit harder to use, but let's go ahead. The last 3 digits are 816. Divided by 8, 102. What happens though if we're not certain whether or not 816 is divisible by 8, or we can't do that quick? Well, if we just divide by 2 3 times, then of course it's divisible by 8. 816 divided by 2 is 408. 408 divided by 2, 204. And 204 divided by 2, 102. It makes sense because 2 cubed is 8. And now to finish it off, 10. Well, we know anything is divisible by 10 if it ends in a 0. Let's pull this together now. Think back to perfect squares. The reason we wanted you to look at those is when I take the square root of a perfect square, I get back that original factor. For example, square root of 9 is 3. So now let's simplify square root of 8. Square root of 8. Let's break it into factors, but I'm looking for factors that are perfect squares. 4 times 2 is 8, so square root of 4 times square root of 2. Square root of 4 is 2, and the square root of 2 is not a perfect square, so it stays in the square root.
Let's try another one. This time we'll mix in our divisibility rules. The square root of 108. Well, 9 was one of our divisibility rules, so let's see if 108 is divisible by 9 since that's a perfect square. 1 plus 0 plus 8 is 9. Well, 9 divided by 9 is 1, so it's divisible by 9. 108 divided by 9 is 12. So I can rewrite the square root of 108 as the square root of 9 times the square root of 12. But wait a minute, there's a perfect square in the square root of 12 because 4 times 3 is 12. So the square root of 12 is the square root of 4 times the square root of 3. Square root of 9 is 3, square root of 4 is 2, and the square root of 3 isn't a perfect square. 3 times 2 is 6, root 3.
Square root of 108. This is when it's pretty cool because someone else might have thought of it a different way. So we can use the divisibility rule for 4, right? The last 2 digits are divisible by 4. 0, 8. 8 is divisible by 4. And then we can figure out 4 times what? Well, 4 times 27. And then we're back down to square root of 4 times square root of 9 times square root 3. Anytime that you know a perfect square is a factor of a number, then you may not need to use divisibility rules.
Square root of 96. I think you got this. Give it a try.
4 square root of 6. We showed 2 different methods that you might have used, but did you use another method? That's fine, just so long as we have 4 square root 6. Look at the next example. We have 2 square root 28. What do we do with the 2 that's out front? Well, it's 2 times square root 28, so just know that I'm multiplying. Let's go ahead and break down square root of 28. Perfect square factors, 4. 4 times 7. So I'll have the 2, then I'll have square root of 4, square root of 7. Simplify, we have 2, then the square root of 4 is 2, so 2 times 2 times square root of 7, and our final answer, 4 square root 7. We've had a lot of guided practice. Now pause the video, try the next 2.
How'd you do? On E, I really wanted to use a 5 to break up that 150, so I wrote it as the square root of 5 times the square root of 30, but then I was stuck because I didn't have a perfect square. So Peart had to help me out a bit.
Now we could have kept going and broken down the square root of 30 and found a perfect square because 5 squared is 25. And hey, think about it, 25, how many quarters are in $1.50? 6. So square root of 25 times square root of 6, 5 square root 6.
Looking at F, square root of 432, I needed that divisibility rule of 4. 32 is divisible by 4, so I knew 432 was divisible by 4.
So then we have 3 times square root of 4 times square root of 108. And hey, we already did square root of 108, so let's just go ahead and use those facts. We have 3 times square root of 4 times square root of 9 times square root of 4 times square root of 3. Simplify all that. Did you get it right?
36 square root 3.